Here is another example. It's a definite integral between 1 and 3 of the product of 4x plus 2 with e to the power of x to the power of 2 plus x dx. You can see immediately that this is a composite function. We have to take the u to be x to the power of 2 plus x. Now let's see what is du. Du is 2x plus 1, don't forget the parentheses, all of that times dx. But this is not exactly what I have. But if instead of 2x plus 1 dx I have 4x plus 2 dx, this is exactly twice du. So what I have here is 2 times du. Okay, now let's focus on that. When x is 1, u is 1 to the power of 2 plus 1, which is 2. And when x is 3, u is 3 to the power of 2, which is 9, plus 3, which is 12. Because we have 2 times du, I can take the 2 out of the integral using the constant rule. And 4x plus 2 dx is just du, and e to the power of x to the power of 2 plus x is e to the power of u. Please always observe that now you have integral which is only an integral of the variable u. No x's, please. Okay, so I'm pretty much ready to do that. The antiderivative is just 2 times e to the u, 2 because of the constant, e to the u because it's the antiderivative of e to the u. And I put the proper limits, 12 and 2. I substitute 12, then I substitute 2. I take the difference, and I got my answer. Example. The integral of x to the power of 5 plus 5x to the 4 minus 5x, all this cubed, time x to the 4 plus 4x cubed minus 1 dx. Okay, I think it's pretty easy to see that this is the composite one. If this is a composite one, then I know what is the u. The u is the inner function, so the u here is the polynomial x to the power of 5 plus 5x to the 4 minus 5x. So the du is, well, differentiate this and time that with dx, and we get 5x to the 4 plus 20x cubed minus 5 dx. But when I'm looking at the left over there, I definitely have only 1/5 of that, because I have only x to the 4 plus 4x cubed minus 1 times dx. So the constant here is going to be 1 over 5. So it's 1 over 5. If you see, the function now is going to be u to the power of 3 du, which equals 1 over 5 because of the constant. The antiderivative of u to the power of 3 is u to the power of 4 over 4 plus c. The only thing left to do is to write now this as a function of x. So now I'm going to replace u by x to the 5th plus 5x to the 4 minus 5x, and please in parentheses because all of this is to the power of 4. And if you look at the denominator, we have 4 times 5, which is 20, and we get that. Now let's do almost the same. The integrand is exactly the same, but now it is the finite integral. Because the integrands are the same, we are using the same u substitution, and we get the same du, and we get the same 1 over 5. The only additional thing is to see what are the limits of integration. So the upper limit in the u is going to be g of 2. So when you substitute 2 into this polynomial of x to the 5th plus 5x to the 4 minus 5x, you get 102. And when you plug 0, you get 0. So here is my new integral. We have 1 over 5 as before, because of the du over 5. Then we have u to the power of 3 as before. We have du as before, but the limits of integration now are between 0 and 102. So we can just evaluate that. Example, sine of cosine x times sine x dx. You can see immediately that this is the composite function and the inner function is cosine x. So du is going to be cosine x. So du is negative sine x dx. We have to do this adjustment because if you look at the integrand, we have sine x dx and the du is negative sine x dx. Okay, so I have to distribute negative 1 there and I get this. So this is negative of the integral of sine u du. The antiderivative of sine u is negative cosine u, so I get that, which can be simplified as cosine of u plus c. Now we have to substitute back cosine x instead of the u, and we get cosine of cosine x plus c. You can easily check your answer by differentiating that. When you differentiate that, you will obviously use the chain rule, and you will get the integrand sine of cosine x times sine of x. This problem is almost like the one that we just did, but this is the finite integral. So in addition of doing all this substitution, I need also to see what are the limits of integration. Where x equals pi, then the u is g of pi or cosine pi, which is negative 1. When x equals 0, then the u, lower limit of the integration, is g of 0, and cosine of 0 is 1. So my new integral is an integral of the u, so it is an integral between 1 and negative 1 of sine u du, and don't forget the minus. So we get cosine of u between negative 1 and 1, and we get cosine of negative 1 minus cosine of 1. Well, I have no idea what is cosine 1, and I have no idea what is cosine negative 1, but I know that cosine is an even function, which means that cosine of negative 1 and cosine 1 are the same, so I get 0. Example, integral between 0 and 5 of x times e to the power of x to the power of 2 dx. This is clearly the composite function, and the only thing that will make this non-composite function if I will substitute that u equals x to the power of 2. So u equals x to the power of 2, so du is 2x dx. But the leftover that I have here is only x dx, so I have to do this manipulation with a constant, so x dx is du over 2. Using the constant rule, I'm going now to have an integral that it's 1 over 2 of the integral. Now pay attention, we have also to translate the limits of integration. Well, x is 5, u is x to the power of 2, which is 25. When x is 0, u is 0 to the power of 2, which is 0. So I end up with 1 over 2 and times the definite integral of u du between 0 and 25. The antiderivative of e to the u is e to the u. So I just get that. And I will plug in the limits. I would like to recall e to the 0 is 1. Be careful. Sometimes when du equals dx, it looks like there is no need to use substitution, but not doing so is totally wrong. I'm now going to do one of the most confusing integrals ever. So what is the integral of e to the 5x dx? Many people will tell you, well, the integral of e to the x dx is just itself, and they really tempt to say that this is e to the power 5x, but this is wrong. This is a composite function. It's not e to the x already. It's e to a function of x. 5 times x, it's a function of x. So in this case, the u has to be 5x, and then you will see what we get here. The du is 5dx, but what I have here is only dx, which means I have 1 over 5 times du. So I have this 1 over 5 integral of eu du. The antiderivative of e to the u is e to the u. Easy. Now it is easy to do because I told you what to do. Because I note to you, don't ever forget that a composite function can be kind of looks like it's not, but it is. So the answer is 1 over 5 times e to the power of 5x plus c. So again, the integral of e to the x dx is indeed e to the x plus c. Yes, but if you have the integral of e of anything that it's not x, it can be x plus 1, x plus 2, 2x plus 1, 3x minus x, then this is totally wrong.